A licensed 9 electrician in Washington state is permitted to install teleconferencing equipment in classrooms or conference rooms. Regarding pulse width modulation, or PWM, underwriters' laboratories, or all power supplies, they can indeed be mounted above ceiling tiles to power Polycom cameras, but with specific stipulations. Firstly, the installation must strictly adhere to the manufacturer's instructions. These instructions will outline critical details regarding mounting orientation, ventilation requirements, and any specific environmental limitations. Secondly, it's crucial to ensure the power supplies are securely fastened to a stable surface. This is to mitigate vibration or any form of movement that could potentially damage the unit or its connections over time. Thirdly, accessibility is paramount. The area above the ceiling tiles must remain readily accessible for future maintenance or repair work. This means avoiding obstructions and ensuring adequate clearance around the power supplies. Now let's address the matter of manufactured molded and marked cables. You cannot install these cables above ceiling tiles in the same room as the equipment unless they meet certain criteria. Firstly, the cables must be listed by a nationally recognized testing laboratory, or NRTL, for the specific application. This listing signifies that the cable has undergone rigorous testing and meets established safety standards for its intended use. NRTLs such as UL Electrical Testing Laboratories, or ETL, and Canadian Standards Association, or CSA, provide the certification. Secondly, the manufacturer must explicitly identify the cables as suitable for use in the particular type of wiring system you are implementing. This information is typically found in the product's documentation or on the cable itself. The National Electrical Code, or NEC, contains various articles relevant to these installations. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. It's important to understand the voltage and current limitations of each class and ensure the power supplies and cables are appropriately rated. Article 300 addresses wiring methods and materials, including requirements for cables installed in concealed spaces. Pay close attention to sections regarding support, protection, and fire resistance. Articles 725.135 and 725.136 deal with the power source limitations for Class 2 and Class 3 circuits, respectively, which are common in teleconferencing equipment. Article 725.135 generally requires that Class 2 power sources do not exceed 30 volts alternating current, or VAC, or 60 volts direct current, or volts DC, and that the power output is limited to a certain value in volt amps. Article 725.136 imposes stricter limitations on Class 3 circuits typically used where higher power levels are needed. Article 725.21 provides general requirements for wiring methods and materials, including conductor sizes and insulation types. Article 725.24 requires that Class 2 and Class 3 cables be separated from power conductors. This separation is important to minimize the risk of interference and voltage induction. Article 725.52 addresses markings of Class 2 and Class 3 power supplies. It specifies the information that must be included in the power supply, such as the voltage and current ratings, the class of the power supply, and the NRTL listing mark. Article 725.130 discusses overcurrent protection, stating that Class 2 and Class 3 power supplies must have overcurrent protection to prevent overheating and fire hazards. Article 725.144 covers the requirements for grounding and bonding of Class 2 and Class 3 circuits to ensure electrical safety and prevent shock hazards. Article 800 pertains to communications circuits, including those used for telecommunications. This article specifies requirements for cable types, installation methods, and grounding. Section 800.24 outlines the general requirements for communication wires and cables. This section mandates that communication cables meet certain safety standards, such as being listed by an NRTL and being suitable for the intended application. Section 800.50 addresses the specific requirements for the installation of communications wires and cables in various locations, including plenums and other environmental airspaces. Section 800.52 details the allowable cable substitutions. It provides guidance on which types of communication cables can be substituted for others based on their electrical and physical characteristics. Section 800.93 covers grounding and bonding requirements for communication systems. It mandates that communication systems be properly grounded to protect against electrical surges and to ensure safety. For cables installed in plenum spaces, which are areas used for environmental air handling, the NEC requires specific cable types with low smoke and flame characteristics. These cables are typically designated as having a CMP rating. Non-plenum rated cables should never be installed in plenum spaces, as they can contribute to the spread of fire and toxic fumes. Cable markings are essential for identifying the cable's type, voltage rating, and intended use. Look for markings such as UL listed, CMP, or other NRTL designations. If the cable lacks these markings, it should not be installed above the ceiling tiles. Remember, local codes and regulations may have additional requirements beyond those outlined in the NEC. Always consult with the local authority having jurisdiction, or OJ, to ensure compliance. In addition to the NEC requirements, consider the following best practices for cable installation. Firstly, always use appropriate cable management techniques. This includes using cable trays, cable ties, and other methods to keep cables organized and supported. Secondly, avoid exceeding the cable's bend radius. Excessive bending can damage the cable's conductors and insulation. Thirdly, protect cables from physical damage. This includes protecting them from sharp edges, abrasion, and excessive weight. Fourthly, properly terminate and connect cables. Use appropriate connectors and tools to ensure secure and reliable connections. Fifthly, test all cable installations. Use a cable tester to verify continuity, polarity, and signal integrity. When working with electrical systems, always prioritize safety. Firstly, de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Thirdly, follow lockout/tagout procedures to prevent accidental re-energization of the circuit. Fourthly, be aware of the potential hazards associated with working near energized equipment. Maintain safe distances and use appropriate barriers and shielding. Fifthly, if you are not qualified to work on electrical systems, do not attempt to do so. Hire a licensed electrician. The use of proper tools is crucial for safe and efficient electrical work. Firstly, use insulated tools. Insulated tools protect you from electrical shock. Secondly, use the right tool for the job. Using the wrong tool can damage the equipment or injure yourself. Thirdly, keep your tools in good condition. Damaged or worn tools can be hazardous. Fourthly, inspect your tools before each use. Look for signs of damage or wear. Fifthly, store your tools properly. Store your tools in a dry, safe place. Understanding the different types of power supplies is essential for selecting the right one for your application. Firstly, linear power supplies are simple and reliable, but they are less efficient and bulkier than switching power supplies. Secondly, switching power supplies are more efficient and compact, but they can generate more noise and are more complex. Thirdly, regulated power supplies maintain a constant output voltage even when the input voltage or load current changes. Fourthly, unregulated power supplies do not maintain a constant output voltage. Fifthly, direct current or DC power supplies provide a constant DC voltage. Sixthly, alternating current or AC power supplies provide an AC voltage. When selecting a power supply, consider the following factors. Firstly, the input voltage. The power supply must be compatible with the available input voltage. Secondly, the output voltage. The power supply must provide the correct output voltage for the equipment it is powering. Thirdly, the output current. The power supply must be able to provide enough current to power the equipment. Fourthly, the power rating. The power supply must have a power rating that is sufficient for the equipment. Fifthly, the efficiency. The power supply should be efficient to minimize energy waste. Sixthly, the size and weight. The power supply should be compact and lightweight. Seventhly, the safety features. The power supply should have safety features such as overvoltage protection, overcurrent protection, and short-circuit protection. The grounding and bonding of electrical systems are essential for safety. Firstly, grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Secondly, bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Thirdly, the grounding electrode system provides a connection to the earth, stabilizing the voltage and providing a reference point for the electrical system. Fourthly, the equipment grounding conductor, or EG, connects the metal parts of the equipment to the grounding system. Fifthly, the neutral conductor carries the unbalanced current from the load back to the source. The installation of electrical equipment must comply with the NEC and local codes. Firstly, electrical equipment must be installed in a neat and workmanlike manner. Secondly, electrical equipment must be properly supported and secured. Thirdly, electrical equipment must be protected from physical damage. Fourthly, electrical equipment must be accessible for maintenance and repair. Fifthly, electrical equipment must be properly labeled and identified. The inspection and testing of electrical systems are essential for ensuring safety and compliance. Firstly, electrical systems should be inspected and tested periodically. Secondly, inspection should be performed by qualified personnel. Thirdly, tests should be performed using calibrated equipment. Fourthly, inspection and test results should be documented. Fifthly, any deficiencies should be corrected promptly. Understanding the NEC is crucial for anyone working with electrical systems. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. Firstly, the NEC is updated every 3 years. Secondly, the NEC is adopted by most states and local jurisdictions. Thirdly, the NEC is a consensus standard, meaning that it is developed by a committee of experts from various fields. Fourthly, the NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Fifthly, the NEC is a complex document, and it is important to have a thorough understanding of it before working on electrical systems. Continuing education is essential for staying up to date with the latest electrical codes and technologies. Firstly, attend seminars and workshops. Secondly, read industry publications. Thirdly, take online courses. Fourthly, join professional organizations. Fifthly, obtain certifications. By following these guidelines and adhering to the NEC and local codes, you can ensure the safe and compliant installation of teleconferencing equipment, power supplies, and cables. Remember to always prioritize safety and consult with qualified professionals when needed.